All right, so let's run through just a little bit of what we had done in 2.3 until we get to our last example. Basically in 2.3 we had come up with, or we had been introduced to the idea of a shortcut way to do derivatives, right? For some derivatives. We haven't explored all the shortcut methods, but we had our first shortcuts here. In particular, we had the constant rule and the derivative of constant 0, the power rule, where you bring the power down and you decrease the power by 1, the constant multiplier rule, where you have the constant that was already there times the derivative of the piece that's got the function x notation in it, and then the sum and difference rule, where you have two functions added or subtracted and you take the individual derivatives of each one. So you guys remember pieces of that, even if you haven't done your homework. That's where we were. All right, so we have one more example in this section before we move on to a little bit more complicated example in section 2.4. So this one right here wants us to find an equation of a tangent line. Now I mentioned this kind of description when we were talking in section 2.1 and in 2.2. In particular, last class period we talked about that phrase, equation of the tangent line. Make sure that you are aware that you're not done once you find the derivative, okay? Because the derivative is necessary, but it's not all of what we're going to find. We're going to find an equation when we're finished. So let's take the derivative first, because the derivative gives us what part of that equation? The slope. The derivative is going to give us the slope. So we're first and foremost going to take the derivative. So what is the derivative of 2x to the 3 halves? What do I do? Right, so the 2 stays, that's the constant multiplier rule. The 3 halves comes down and gets multiplied by it. And then I've got an x, and the power will decrease by 1. So if I take 3 halves and I decrease it by 1, what do I get? 1/2. Very good. Now we'll do that same process for the second piece, the negative 3x to the negative 1/2. So I've still got negative 3, and then what do I have? Times negative 1/2, good. X to what power? Minus 3 halves. Okay, we're going to clean up just a touch right here because we can. And then we're going to let our calculator evaluate this for us. We do not need to worry with square roots and things like that to actually do the evaluation. Our calculator is perfectly comfortable and capable of doing that for us. But I am going to go ahead and simplify this because I don't want to put a whole bunch of parentheses in my calculator. So I've got 2 times 3 halves, that's just 3. So this is 3x to the 1/2, or you could write that if you preferred in your calculator as 3 squared of x. That'd be fine as well. The other piece would be plus, this is 3 halves, or you could write it as a 1.5. I'm just writing alternate notations if you like them better. And then I wouldn't even worry about changing this. You can write it as x to the negative 3 halves, or if you don't like to have fractional exponents, you can do negative 1.5. That's what 3 halves is. So either of those notations, it doesn't matter because that's not really our answer, right? Our answer is to figure out what the slope is. Well, our slope is going to be evaluating this at what point? 4, exactly. So you can take your calculator and you can do it one of two ways. You can just flat out plug it in piece by piece into the equation or into the regular menu in your calculator, or you can put the equation, one of these versions of it, into y equals and you can plug it in the table. Either of those will work just fine. Okay, when you have an answer, just kind of look at me and let me know that you've got a value for this. I believe it's an ugly value, so make sure you turn it back into a fraction so we don't have any, or a decimal. Does a decimal terminate? Does it stop? What's that? Does? Yours does? Okay. So you can either use the ugly decimal or you can turn it back into a fraction. It's going to be an ugly fraction too, so whichever one you prefer. It's really not a big deal either way. Now, if you end up with a fraction, if you end up with a decimal that doesn't stop, it doesn't terminate, then we want to make sure we leave it in fraction form. So, okay, Christian, what do you have?
6.187.
Tristan, is that what you had? Excellent. Did anybody turn it into a fraction form? Do you know how from your calculator? Okay, let me show you how to do it from your calculator, because if it's not already in a completed decimal form, a terminating form, I do want it turned back into a fraction. You hit math, just from the wherever decimal, ugly decimal you have, hit math. The first one should say frac with a little arrow on the end or before it, I can't remember. And hit frac and then hit enter, and it will turn your decimal answer back into a fraction. What'd you guys get? 99 over 16 is correct. So either of those are perfectly fine in this particular problem. Either of those. Are we done? No, why not?
Because we have to find the equation of the line.
All right, so an equation of a tangent line means, well, we can anyway, start out with y minus y1 equals m times x minus x1. Tell me what we know so far. What have we found? We have found m, the slope. What other piece of information do we know? Yeah, I typed it in wrong. The x value, what is the x1 value? It's 4. It's given to us right here. So this is 6.1875. And what in the world am I going to do to find the y1 value? Right, I need to plug the x value into the original function. So my y1 value is going to be finding the original function f with the number 4 plugged in. And again, your calculator will do that for you just fine. And it's not quite as ugly. In fact, it's not an ugly fraction or decimal at all on that one. What did you get?
14.5.
14.5 sounds correct to me. Do I have a second? Going once, going twice. Yes, so good. That's fabulous. All right, so we've got this one then as 14.5. We'll do it in decimal form on this. We don't need to do it both ways, and decimals work just fine. All right, so we're going to plug those numbers in and simplify our result. So right now we have y minus 14.5 equals 6.1875 times x minus 4. And we will solve this for y equals. So y minus 14.5, and we'll distribute 6.1875x. What is 6.1875 times 4?
24.75.
All right, 24.75. And then what's our last step? Add the 14.5. So I have y equals 6.1875x minus what? 10.25. And just so that you have it in case you do prefer working in fractions or wanted to verify it with, the back of the book's probably going to put it in fractions, let me just tell you that. It's actually 99 over 16 x minus 41 over 4. That's what it is in fractional form. Again, as long as the fractions actually terminate as decimals, I'm fine with the decimal form. Yes, Darby?
How did you get the 14.5? What did you plug in?
We plugged in the equation right here, the original equation right here, we plugged in the value 4.
Oh, okay.
Right, so the x value of 4 has a corresponding y value or a function value when we plug in the same number 4. Yep. Any other questions on that one? So that one kind of took it a step further than the other examples we did last time because we actually found a tangent line when we were done. We didn't just stop with finding the derivative evaluated at a point. All right.